We're just going to do like that quickly. And transition over. So we're getting an uncaught exception here. Which is always fun. And they're suggesting compile with /-s demangle support to link in demangling, because right now we are getting really, really wonderful things. So I can see something about add face x negative here. But I think we're just gonna go with this. Apparently we're calling a port at some point, which is always fun. So yeah, it's gonna be interesting to see why that. Oh wait, I have a pretty good idea why that's happening. So we have this wonderful vertex data, which is edges by edges by edges. It now needs to be by 6 because we need it in each of the 6 facing directions. So let's try that. So we build it again, link it. Yeah, just to inform, so, because I forgot to switch over. So we had these edges times edges times edges vertex arrays. We now need an extra times 6 for the facing direction. And we change this here as well so that they match. And with any luck, we should be working now. Yeah, great. So it has changed a little bit, but that's probably just, I don't know, something up, or rather the down faces don't really seem to be getting drawn. Which actually makes good sense now that I think about it, because we are going until we're less than down, we need to be less than or equal to down so that we also get the down faces generated. So let's just see how that goes. And a shout out to Magic and or Panda and Beyond, who decided to tune in, and I've just read the chat about an hour later. Let's give this a go. Yep, we got a downwards facing side as well. Great. So we have every side in place. Now we need to generate the texture coordinates. So that's these wonderful SMT things. So the way we're actually doing it right now is that we're generating these in our vertex shader. So what we're doing right now is that we are, fragment shader here, where we're actually taking that. We are looking at the color value, and we're just taking the X and Y as our index into that, and our color value here is just our vertex coordinates plus a half to sort of normalize it a bit, and then we're just looping around. So we're basically taking the X and Y coordinates as our texture coordinates, and we are going to start by doing the same, just not offset, because that sort of gives us a base to work against. There we go. And then once we get a little bit further, we're actually going to generate reasonable values for this, but it's all about getting stuff working. So we're going to start by doing that. So now we have our texture coordinates created, and that should hopefully still work. There we go. Yeah, that looks good. Nothing new and exciting happening, but we're getting somewhere. So now what we need to do is we're pulling in here as an attribute, we're pulling in our vertex coordinate. We now also need to pull in texture coordinate, and this is a 2D vector. So this is, we're going to call that texture coord. And we're actually going to have to output that as a varying variable to our fragment shader so that it knows what to do. So we're going to have texture coordinates, and this is going to look stupid, But what we need to do is we need to assign that across, and this is not gonna work. So we're just gonna call this, well, we're gonna call this frag texture coordinate, or rather we're gonna call this varying texture coordinate. So we're gonna copy that across. And then over here, we're gonna have the same varying here. And we are gonna do this low precision because honestly, we're probably not gonna need any more than that. And then we are gonna index our base texture with the varying texture coordinates so that we get those across. And that is essentially it. And we're just gonna clean and rebuild here. Should probably add dependencies at some point so that it picks up that we've changed these files and recompiles. But right now we're just going to do it this way. So we link it, we've built it, and we should hopefully see, yeah, funky stuff going on. So you can sort of see that we have our sphere here. It's a little bit hard, but if you know what to look for, it's definitely there. But right now, the texture coordinates are just random noise. We're reading from somewhere random in graphics card memory. So we need to link up that data. And the way we do that is the same way as with the other stuff we've done. We have a vertex program. So in addition to the vertex attribute, which we're passing in here, we also need a texture coordinate attribute. So we're going to call this texture coord attrib. So we have our vertex buffer bound, which is fine. We're then also going to find our texture coordinate here. We're passing in 2 floats. They're normalized. The tires, we're striding with that, and this time we're not going to offset with the vertex coordinates, but with the texture coordinates. Offset texture coordinates. Have I? Okay, I should probably, just for consistency, because I've been sort of annoyed by this, call these offset as well, because that makes a lot better sense when we're actually using them. So I'm just going to rename them over here as well. So now our chunk renderer should be ready to handle the texture coordinates. So we're going to need to have to change the signature here, which comes also from the concept of our GLES renderables. So we have to overwrite this one so that it's different. This is going to become a lot more pretty at some point, where we're going to factor a lot of this stuff out into the concept of a material, which means we just render it with a material, or rather we set up the material and then we render it with that. Anyways, let's move on. So when we call this in our renderer down here, we call render somewhere, I assume. This is all the texture setup and stuff, and the gradient of our program. And here we're loading in that texture, which is fine. So here we have our vertex location. We also want the texture coord location. So what I want to do is I want to see that's there. So in addition to getting our vertex, we want from our shader program, we have this, not that one. The texture coordinate, we want to grab the location of that as well. Or was the GLES renderer? Threw it away. There it is. So from our shader program, we also grab the texture coordinate and then we render with that. So if we build that, yeah, and our cube here is very wrong because it still doesn't have its texture coordinates. But now if we look at these, we get nice texture coordinates and what appears to be a little bit of Z fighting. That is probably the interpolation doing really weird stuff, would be my guess, because it seems to be a little bit dependent on how far away the texture is, or rather the angle at which I'm showing it. So it's probably weird interpolation because we're at the edge of the texture at that point. So now we need to generate those in a sane way. And what would be nice to do, if I can find it, chunk renderer here, is to sort of do the same. We have these XY things, which are really wonderful. What we'd like to do is we'd kind of like to, depending on which direction we're facing, use different coordinates, and then basically do it modulo 2 so that it's either 0 or 1 and alternating, so that along a face you'll have 0, 1, 0, 1, 0, 1. Because by doing it that way, we sort of we rotate and mirror the texture in such a way that we don't really need to worry about it being seamless, because we'll just mirror it across an edge. That way it will match. It's gonna look a little bit odd at first, at least. It might actually work as we go down the road, but we'll see how that works out. So what we'd like to do is we'd like to figure out what we're gonna use. So sort of the easiest way to do this would just be saying like this, and then y modulo 2. But that's basically what we're doing already, only a little slightly different. So if we just refresh that, what you see is that we're sort of mirroring them along the edge. I'm getting a slight graphical glitch right at the edge. And we get this wonderful effect. But we still have this problem when we're going along the z-axis. So this is like the east and west, and the up and down faces will have this as well. If we go inside, we can look down on them. Yeah, so we have all these faces. So this works great for like the north and south, because that's along the z-axis, so that's great. So what we're going to do is we're going to say if our facing, this is going to be really, really horrible, is direction north, or our facing is direction south, then we are going to use this. Otherwise, so if we're up, down, or east, west, we're going to use the z-axis instead. And we'll see what that does. That should fix some of it. So now we have sane along northeast and southwest, or north, south, and east, west. So now we're looking at up, down. We need to fix that. So the thing is that when we're doing up, down, we're going along the y-axis, which means this isn't changing. So what I'd like to do is to say when we're going up, down, so if this is up, or it's down, then I'd like to use X instead. Otherwise, I'm going to use Y. And we link that, and we reload. And we now have decent texturing on all the sides. So we now have something that looks like halfway decent texture coordinates. There's a little bit of discontinuity with them along edges, like here. But that's going to be really, really hard to fix, because then we're just going to break it along an edge like this one. So it just give you that in. So like we have a little bit of discontinuity here, which would require that we flip this texture here. But if we flip this texture, then it's not going to match here. and that has to match so that that matches. Technically, we could offset a little bit depending on which layer we're at, but honestly, I don't think it's worth it. But we have a little bit of a sphere with texturing. So the next step is that we are gonna do a little bit of sort of factoring. Well, we're gonna kill off this wonderful little cube in the middle. It's been wonderful having it to help, but now it's just missing texture coordinates and our shader doesn't work with it. So we're gonna kill that off. And then we're gonna move on to sort of factoring out a little bit of the material code so that we can load that from a file. But to do that, or before that, we're going to have a little bit of a break. But first, we are going to get rid of that cube. And I think we're rendering it directly here. So we just kill off that block and the render call. And we take a look at that. We link it, and there we go. And it's gone. So we're just going to do a quick little 13 minutes of break, I can see. So we'll be back at 8 o'clock to work on separating out some material code and getting that into a config file essentially, which tells us what textures to load and what shaders to load, so that we can sort of alternate that. But yeah, get up, have a little break, grab something to drink, whatever, and we're back. So we want to sort of factor out a little bit of this material code so that we can read it from a configuration file rather than hard code what textures and shaders we're going to be using. Of course, this is going to start with us hard coding the material file instead, but at some point you gotta hard code stuff. So let's sort of jump right in. So get you guys the code as well. There we go. Now we have this wonderful stuff here. We are going to create a GLES material, which is going to be responsible for all of this wonderful stuff. So GLES material. So we have this wonderful thing. We are going to initialize a GLES material based on a name. And then we are going to have a void function called activate, which will basically set up OpenGL so that it is using this material. And that's sort of going to be our interface that we're going for. And in this, we are going to really capture a lot of stuff, like creating shader programs, the loading of our textures, and getting the uniform locations and stuff like that. Actually, our vertex shader, this is going to be interesting because we need to transfer a model and view transform into it, which I guess isn't really interesting for the material, so we're not going to go for the vertex shader. Is probably not going to be part of the material, but the fragment shader is, which means we need a standardized interface between fragment and vertex shaders, which is going to be interesting, to say the least. Yeah, we'll get to that. But then again, there's sort of like only so many attributes you can transfer. Like we have a vertex location, we have a texture coordinate, and we have a normal, which is sort of the main things that our base vertex shader is going to be interested in anyway. So we're probably just going to hard code the names for that. But yeah. let's see what we can do. So I've been thinking a little bit, or rather I've made a decision. We're gonna sort of do this description in YAML syntax, and luckily there's a library for C++ with a YAML parser and emitter that we're gonna try and include and see if we can't get to work with this. So we're just gonna set up the project for pulling that in first. So what we're gonna do is I'm gonna quickly switch to a terminal here. Is that we are gonna create a quick external directory here, which will be useful for having these kind of things. And then we are gonna pull in a git submodule, and because I suck at remembering how that works, git submodule add, and then we are just going to grab this. So now we should have a project included here, and it looks like we have it. And it's also a CMake project. Fortunately, we probably can't just say go build it to CMake. I mean, we can try. So if we have CMake, at this point I want you to go add a subdirectory. We have external / YAML CPP. So something definitely happened, and this is creating a lot of extra targets. As long as Longshot is still my main, I don't really care. So now this will create a set of targets as well, so we're going to want to link against one of those, would be my guess. So target link libraries. So Longshot should link against, and I need to figure out what that might be. There's one called YAML CPP, so let's guess that one. If we try building, well, it definitely causes a lot of YAML stuff to be built. And it does seem like we successfully link, so that's a good thing. So let's see how we use this. See the tutorial. So we load a file, and then we can just sort of use standard indexing operations. Great. That should be doable. And there's an include folder here for YAML CPP with a YAML.h there. So what we are going to do is we're going to look at our alias material here. So when we implement this, what we are going to do is we are going to create a file name, which will be materials plus the name plus YAML. So it's going to expect sort of this structure. And then we are going to say we're going to create a YAML node. Yeah, I'm probably going to nicen that up in a bit. Description. Yes, this is going to be a description of... There we go. Apparently CLine just had a little bit of a break. And we're going to go for YAML load file. And we're going to load it from our file name, and you can include that as well. There we go. What are we complaining about? Cannot resolve namespace member load file. Yeah, see, we're sort of expecting some include paths here so that we can do this sort of thing instead. So in our CMake, we also have target include directories for Longshot. I would like to include external YAML cpp/include. Am I not using this right? Just quickly. So target mylib that may not be an imported target. Interface public and private keywords are suspended. Private and public items will populate include. Public and interface items will include the interface include directories. You may specify. Okay. So what we want to do is we want to do this private. At least that's sort of my thinking here. Compile again. Yeah, that linked perfectly. So there's a chance that something's working. So what we'd like to do here is that we would like to, just for testing, create a GLES material. Matte, and we want to create the stone material. And yes, you may import that. So if we do that, we should link correctly. We get an unresolved symbol, YAML load file.